Hello and welcome everyone. In this topic, we're going to discuss the LSA Type 2, the OSPF LSA Type 2, followed by the OSPF network types. Why we're doing the topics in this order? Because this is a customized course talking about the service provider, and when you implement the routing protocol in this area, and you are just working in this area in the first place, it's something, it's not new for you. You came from long experience configuring OSPF and stuff. So in this course, we're going to link all the feature side by side and how we use these features together in conjunction with each other. So to just get the benefit, to get the full overview, to use the benefits of these features in your implementation if you are working in this environment. So, okay, let's talk about LSA Type 2. I assume that you already know what the LSA Type 2. What is the LSA Type 2? Okay. Agreed that in the OSPF design, when there is layer 2 data link layer is the Ethernet, the OSPF acts like what? Acts that this is a multi-access network. So let's just ask ourselves a question. What's the default behavior in the Ethernet network? How the OSPF operates, how the OSPF acts, how the OSPF sends its message, how the OSPF build this network and build it in the database. Actually, there is a difference between when the OSPF acts and operate over the serial link. Maybe the serial link has an encapsulation like triple B or HDLC or frame relay. It's totally different when the OSPF operates over Ethernet links. So first, it's about the layer 2 encapsulation here. The OSPF detects the layer 2 encapsulation and then will act as it. Will change the behavior. Okay? So what is the LSA type 2? This is just make us go back a little bit to say how the OSPF operates in the Ethernet network, what's the DR, what's the BDR, what's the communication channel using the DR and BDR. So this particular point is really important when we talk about LSA type 2, and then the next point, how we just optimize and reduce or just take the benefits from taking out this feature, taking out this LSA, or just leave it there. So let's just take an example here. I will take router 2 and 12. These two routers. Okay. So this is an Ethernet link. Let's take router 11. I'll say show IB OSPF neighbor. Okay. It seems that we have two neighbors, which is router 2 and router 12. So if we look to the neighbor table here, we see that there is a fall slash BDR. So what is that? Backup designated router. Well, just bring router 2 to the picture and ask him the same question. For simplicity and clearing the point, I'm going to close the link E02 to router 5, and E01 to router 12. Shut down. So where this going to leave us? To show IB. Come on. We have only one neighbor from router 11 perspective. Router 2. Only one neighbor. But let's just see this. This is a DR. Router 2 seeing router 11 DR. Router 11 seeing router 2 as a BDR. So what is that? Okay, before going deep in this point, I'm going to do what? To shut down the OSPF on router, let's say 11. Okay, 11 and 12. Router, I need you to focus, guys, and concentrate, because this is linked together. If you just miss the point, you can't understand the next point. Got it? So shut down. Shut down. I'm going to wait a little bit. Okay, I'm going to no shot router 2. Okay, then I'm going to do the following. Remember that router 11 is shut down. Okay, shut down. Router 2, no shutdown. So the OSPF is operational on this link. Router 11, we shut down the OSPF. This is meaning the OSPF is shut down on this link too. So I'm doing this. From router 11, I'm going to do the following. First, I will just disable this domain YB domain lookup, and say then do Bing to as you can see here, router I pinged this multicast address 224.0.0.5, but who's answering me? Where is this link here? E02 do show IB interface brief. E02, this is the link. Router 2 is answering me, meaning what? Meaning, and also router 11 itself answering himself on this query and this ping. I'm going to also close the loopback 0 on router 11 to just make the picture clear enough. Interface loopback 0 shut down, and then we're going to repeat the ping too many times. Repeat 10. As you can see, the only person who's replying to this multicast ping is 2. Okay? Why? Why? This is simple normal question we were talking when we're talking about the OSPF. OSPF using this multicast channel to send their hello message to build the neighbor relationship, right? So if you run OSPF on this link and you don't run OSPF at all in this router, but you are running the OSPF in this link and enabling the OSPF in this link, and from the other side you ping the multicast 224.0.0.5, the OSPF on this link will answer you back. The router 2 will reply back to you. Okay, so the physical interface replying to you when you ping this multicast address. So what's the point? Okay, just focus, be patient, we'll just make it step by step. Okay, so I'm going to shut down router 2 again. Router OSPF 1 and shut down. Just make sure interface E03, which is this interface linking router 11, shut down, and get back to the OSPF. Router OSPF 1, no shut down, and get back to the interface. We'll say no shut. No shut. Now the router 2 will start sending OSPF hello message to the other side, but even just disabling the OSPF will no answering this settings. Okay, remember I'm pinging now to 224.0.0.6, not 5. Okay, so it should time out until certain amount of time and I will have a reply. Why? Why? You should take a note. Now you see, now I have a reply from the same address. But why waiting all this time? And what is the specific time while this timing out will end? Right? So what about this address in the first place? Okay, let's get back to the picture again about the Ethernet, the OSPF behavior on the Ethernet network. While the OSPF is running on the Ethernet network, we need to elect something called the DR and BDR. What's the purpose from electing DR and BDR? Reducing the amount of communication, because there could be a switch here. It will be too many routers on the link sharing the OSPF neighbor relationship. So if we expecting from each one to send the update to all the neighbors, it's going to have a huge amount of update exchange in the network. So we need a behavior, we need an approach to reduce this amount of communication. That's why there is a DR and BDR election there. Okay, I'm going to elect a DR and BDR, and each one in the network, each one in the segment in this link will send its update to the DR. Of course, the BDR will listen to the update, but the actual one who going to response and update all the network about this specific neighborship's update, only the DR will act. So DR will receive the update on the multicast channel to 24006. So why is there is a timeout first? Because there is a steps between the two neighbors to who's going to be the DR, who's going to be the DR, the one with the highest priority. If the priority is tied, then we're going to who has the highest loopback address on the interfaces, on their interfaces. But what we have if we have in the loopback in the routers, we can look at the physical IP address on the physical interfaces. So, or even you just go to the OSPF configuration and you say router ID, blah 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 blah. You just reinforce hard code the router ID. So the router ID, the one with the higher router ID will be elected as a DR. So so what this has to do with our point LSA type 2. So you're being elected as a DR. Now you, only you're going to generate a specific LSA, will be listed in the OSPF database as a LSA type 2, named what? Named a network LSA. So in this design, so as you can see, all the link is Ethernet. Meaning what? Meaning what, guys? Meaning what, Ammar?
A
How
link will have DR and DDR.
Bravo. Each link on the topology will have its own DR and BDR. So between 2 and 5 will be DR and BDR. Between 2 and 11 will be DR and BDR. Same, 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 same. As long as you go. And inside the area, the LSA type 2, which is network LSA, which is generated by the DR in the network, will be listed on each router on the topology. This is of course going to be a huge if your network is big, is scaled, and too many DRs there. Yeah, but let's just first have a look at the LSA type 2 in the database, and how can we change the behavior, how can we take the LSA type 2 out. Can we do this? Yes, we can do this. Okay guys, so I'm going to just no shut down the link that I shut down, interface E01 on 11, no shut, and face E02, no shut. So from router 2's perspective, if we say do show IP OSPF database network, can you see this? Oh, we have a big output here. This output, if we just take a look, this is router 2 output here under the process ID 1. So the network link state in area 0 will be the following. Router 9, just where is 9? Here is 9. 9 is a DR. Why is listed in router 2? Because, hey man, we're talking about OSPF default behavior. Every router on the topology inside the area should have the same copy of LSA, whatever their type. We're talking, let's say type 1 or type. Anyway, inside the same area, all the routers should have the copy of the OSPF database. This is normal behavior of the OSPF. So router 9 generating LSA type 2. and router 5 generating LSA type 2, router 7 generating. These guys, they are a DR, my friends. Okay, so 7 a DR, router 4 is a DR, router 5 again is a DR on another link, router 4 is a DR on another link, because as you can see, router 4 is just linked another 3 routers or 4 routers in here. You'll see that router 4 generating too many LSA type 2. Okay, guys? 8, 199, 199 again, 11. Okay, guys? So, this is the same output if you just go to router 3 here. And we'll say same thing, show IP OSPF database network. You will see the same output, normal behavior regarding the OSPF building its own topology. Okay, this is the second LSA inside the OSPF database. Okay, generated by what? Generated by the DR. Okay, let's just from router 2's perspective, I think he's a DR. Let's just take a deeper look about this output. Do show IP OSPF neighbor. No neighbor. Why? Yeah, because we are do show run session OSPF. Yeah, because we're just shutting down the router. Or OSPF 1. No shut. If we say this show IP OSPF neighbor, you can see that router 11 seeing router 2 is a DR. But why? You told me in the a little bit that the one with the higher router ID will be a DR. Yes, this is right, but router 11 came back later. Router 2 came up first, and router 2 will send the hello message one time, 10 seconds, two time, another 10 seconds, three time, another 10 seconds, four times, another 10 seconds. So if no reply back, if no communication regarding the OSPF neighbor relationship, router 2 will elect itself as a DR. So this is a normal behavior. Okay, so from router 2, if we can say do show IP OSPF database network 1112. I think there is something. Show IP OSPF database network no. Why? Show IP OSPF database. This is LSA type 1. The LSA type 2. So what about the link between router 2 and router 11? Okay, let's find it here. Okay. This is the LSA type 2 that router 2 generated. The LSA type, it's a network link. The link state ID about this L2, this LSA type 2, describing the address of designated router on this link. Who's advertising this? Router 2 advertising this LSA type 2. This is the sequence of LSA type 2. This is the integrity checksum. This is the length, the subnet mask of the network over this link. Who's the router that attached to the network, to the link? We have only two right now, which is router 2 and router 11. If we have another routers, they were listed here too. Okay, guys, so this is the LSA type 2 generated by the DR inside the Ethernet network, inside the same area, will be disseminated on each router in the topology. Um, and the next step, on the next video, we will talk how we optimize the behavior regarding this LSA type 2. We can take it out by doing what exactly? We will answer this question when we get there. So stay tuned, guys. See you next.